Alright, this is MSE110, Project 3, Group 3, PM Lab. In the case that the physical version of our robot does not work, we have a virtual version of the robot working flawlessly. This is the version that will be presented on the robot LCD, and essentially we give it a start and end point, and the robot will solve the maze virtually on its LCD. So we have the start and end points given here as 0, 0 and 3, 5, which are essentially just the two corners of the maze to keep things straightforward. What this will do is this will go from the start point to the end point, record each of these different directions that the robot takes into an array, remove all 180-degree turns from that array, and then use a switch to switch the values throughout each of the arrays. So for example, north becomes south and east becomes west, vice versa, and it will then iterate through this array from the end to the start, which will essentially work its way backwards from the end to the start on the maze, which will essentially be the shortest path algorithm. All of the arrays will be printed to this data stream here, and we have the robot LCD here to see just how it works. Of course, you can also look at the robot LCD itself, and this will also have the same maze with the same data being printed to it. Nonetheless, we're going to run that specific code here with the following start and end points and see how it goes. As you can see, we have set a start and end point which are present, the S and E, in the different corners of the maze. It is using the right hand wall algorithm to determine where it needs to go, and it successfully works its way up to the end point. It says that the maze is solved and is returning now. If we look at the data stream, it will return all of these different directions, reverse it, shorten it, and then go back. Now we use that shortest path, skipping any 180-degree turns, and successfully making it back. Now assuming that we simply just call physical functions, as you can see here, we have physical functions. Let's say the robot virtually makes a move left or right. We will simply call a physical function to move the encoders left or right, or forward. However, there are unforeseen circumstances like drift or anything like that in the maze. So in the case that something like that happens, we have this virtual version of the robot which perfectly works and successfully goes through all the different expected outcomes for the assignment in a virtual form. Alright, so that is the video. Thank you.